I would like to talk to you today about self-consciousness. I also prone to propose that self-consciousness is based on how the brain represents the body. And finally, I'm going to go to my third topic, which is cognitive neuroprosthetics. Cognitive neuroprosthetics, how I see it, is a new field which tries to study and build models of self-consciousness in order to project them onto artificial limbs, avatars, and robots. So what is the self? The self is the subject of conscious experience. Experiences are experiences for somebody, for me, for you. We all feel this. We all are introspectively linked to this experience that we have, which makes our experiences private. But what is this entity? This is actually not just experiences that are self-attributed, are felt as my experience. If I move my right hand, this is my movement. But what in the brain generates the sensation that this is actually my movement? This goes for thoughts as well. I have a thought right now, you will have another thought. There is an ownership to those thoughts. They are self-attributed. So the self has been studied, as you see on the screen, over 2,000 years, probably much longer. Mostly by philosophy, more recent by psychology, and most recently by cognitive neuroscientists. Memory is, of course, an important aspect of the self. I remember the last time I was in Lausanne. I remember more or less what I ate this morning. I remember where I was told to be born, etc. These are important aspects of the self, of our identity. And people have proposed this is how we have to study the self. The most famous statement in Western philosophy, René Descartes, is marked on the screen, cogito ergo sum. I think, therefore I am. So this puts really a high-level cognition, memory, the example before, now thinking and thought as the way we should understand the self. And probably most of us, sometimes including me, think, well, this must be the basis of self-consciousness. I'm going to argue this is wrong. It starts much too high. By using these mechanisms, we're excluding most of the species. Not even in monkeys, our closest relatives, or chimpanzees, we could study this because they don't have language. So we need to have an approach, a neurobiological approach, and the first approach that people took was the so-called visual mirror self-recognition task, which even some animals can pass. But I'm going to argue this is not low-level enough. What I'm going to argue, as I told you already before, is that the body representation of the brain is the most crucial. And if I play you the next video, please, then you will see a very simple example how we can change what is self and what is not self. Look in particular at the left arm of the blue subject. So first of all, it's always... If you play this with sound, it's even more fun. But I mean, first of all, neuroscientists can have fun in the laboratory. That's already a good thing. Not so sure about the blue person. If you can stop the video right now, I can explain you what is actually done. This is a simple trick. This person, a lifelong experience, should know what his hand is and what is not his hand, okay? A few minutes of stroking between the hand that you see on the right, he doesn't see it, he only feels the brushing, and then there is the hand in the middle which is seen. It's a ridiculously looking fake hand. We all have examples of that probably at home, more or less. But what is done here, that the experimenter puts a conflict, because normally when we're looking at our hand, when I touch it right now, the touch cue and the visual cue is on the same position in space. But what is done here, a simple trick, the subject even knows what is done to him. Remember, thought was important for Descartes. Thought is the same, but still you make an error. What is your body, what is not your body? This is called the rubber hand illusion and has been studied by many people and can change ownership. It can change what you judge as being your body and not your body. On the next slide, I show you a few basics of the rubber hand illusion. On the left side, you see that if you ask people in the rubber hand illusion, the person in the blue shirt, to ask how strong is his sensation that the hand that he sees, the pink one, is his own hand, he rates this very highly. However, when you put a temporal conflict, if he feels the touch of the hand that he doesn't see at a different moment in time than the touch cue is applied on the visual hand, this illusion breaks down. And this is what is shown in the middle. In addition, This is just subjective questionnaire changes you may ask. But what is interesting here, researchers have asked, so I'm the person in the blue t-shirt now, to point towards the hand. A very simple task. You just ask to point towards your body. What could be more simple than this? You can't make errors on this. But if you ask the subject to do it, he actually points not to his real hand, but he now, with eyes closed, points, shifted and drifted towards the fake hand's position. What does this mean? Well, I think it means that the brain starts perceiving, not thinking, perceiving that actually my hand is at the position of the pink hand. And of course, you can link this with cognitive neuroimaging techniques, and we can describe, as is shown on the middle, we can describe the brain region involved in this. Now, what is necessary for this field, before I go to cognitive neuroprosthetics and how this can be used, these scientific findings about the self, is that we need better descriptions. We not just need to stroke for 1 minute. Imagine you would be an experiment like I just shown you, but for periods of time, for long periods of times, several hours per day. Your brain would probably think and disembody the real hand and start embodying the other hand. And this is actually what we've tried to test with few examples and studies, developing models, mathematical models, when selfhood is ascribed to the fake hand. This is what's shown on the right side. And then we've also looking at the brain signals that are involved in this. However, another example what bodily aspects of consciousness are phantom limb sensations. This is even one more level forward. You can feel having a body without actually having that body part attached to your body. Here, the right upper arm in this patient is completely missing. But what he feels is the persistence of a flesh-like hand on the right side. And what is striking is that this hand here, on the right side, is felt in a similar way as that on the left side. So first I showed you we can trick bodily self-consciousness in healthy subjects. Here you can have bodily self-consciousness for body parts that do not even exist. And we know that this is due to the changes in the brain in parietal cortex. Now, what is cognitive neuroprosthetics? The first example I want to show you here, remember cognitive neuroprosthetics is projecting selfhood to artificial limbs, what we're trying to do, and I want to show you in the next video. This is work by my colleague Todd Kuiken, is that ownership and the rubber hand illusion can be induced if you have mathematical models in an operationalized, automatized fashion. So here, the prosthetic limb that you see here in this patient, or moving in this patient here, actually you see that this is the stump, this is a left upper limb amputee, and touch cues, like in the rubber hand that you apply at the hand, and that is only seen. Now this is a plastic hand, a very smart hand, as you can see here, but these touches are linked at dedicated position onto the arm of the subject. So now you can create new connections between a fake hand and this robotic hand. And what is important, robotic hands can move, as you can see, but they do not feel yet. So cognitive neuroprosthetics will allow prosthetic limbs to mediate touch sensations and ownership. Tools. Actually, these mechanisms are not just at work in amputee patients and in the rubber hand illusion. We all carry tools around in our hand all the time. Actually, clothes could almost be a tool. But what, and if we've just talked about phantom limb sensations, you can wonder whether these stars that I grew up with, giving away a little bit my age, but John McEnroe, what would happen if John McEnroe, as he's doing now, does not use or hold his tennis racket in his left hand? Will he have phantom racket sensations? But the data that I show you just here next to it, coming from animal experience, show that this is what we should predict. Because I've shown you, you can easily change what kind of body part is yours or not yours. Well, lifelong experience holding a racket in your left hand can actually change how your brain represents body. Because using tools for several minutes per day changes in this brain area here in the parietal cortex what the monkey's brain perceives as body or not body. So after tool use, a touch cue applied to the fingertip activates one neuron, and the same neuron will also be activated when now, after the tool use, the tip of the tool, the tennis racket in the human case, is studied. But to give you one more example, if you play the next video, please. This is actually not tennis players we're looking at. Actually, what we're doing right now is surgeons at Geneva University Hospital. We're studying how their brain changes, but not using and playing tennis, but they are actually much more sophisticated, using very expensive robotic surgery systems that allow them to improve surgery and carry out minimally invasive surgery. So now we have for the first time the possibility to go beyond just simply handheld tools, but really look at what happens if, okay, sorry about that, if this huge robot that you have seen that's inside carrying out the fine operations is linked to fine-grained finger movements. How does the brain represent this? Are we speaking about a new brain function? Yes, we do. This has never been possible before. The question is, what happens to this area, the brain region that I've just described to you before? What are the changes? Actually, I think the brain will change as we move on, and all of us will be in touch with more and more cognitive neuroprosthetics. But wait a minute now. I've talked about self-consciousness and about this entity that is supposed to be the subject of experience. You see this beautifully in these two self-portraits on the left by Escher and by Mach on the right. There is this entire entity that seems to be directed against the world. It's not about hands being part of this entity or not. It's me here looking at you and you over there looking at me. So how can we study this? And what we've done in the lab over the last 6-7 years is to develop methods using virtual reality and also robotics to map and to measure what is this a full body representation. Because what we have found is that what can be observed for the rubber hand illusion can also be induced in something we initially wanted to call a rubber body illusion, but after checking the web and the internet for a little while, we decided to go for another type of name for that illusion, calling it the FBI or the full body illusion. But what we induce, again, I'll be brief, is that we can induce similar states. So watching, if you play the video in the middle, please, if you stroke now the body of the subject in the middle, so you feel the touches behind you, and you see the touches applied to an avatar's back that's standing 2 meters in front, and you do this synchronously, just like in the case of the rubber hand illusion, well, then you will self-attribute, or you feel that this avatar's body is your body. If we ask you, after the stroking is over, close your eyes, we displace you, and you're supposed to go back to your position, in this case, the red carpet, people know exactly where they're going. But with closed eyes, they're walking too far. They're walking where? They're walking, they have recalibrated not their arm position, but the entire position of their body. So you get these two changes for the rubber hand illusion, now here for the full body illusion. Now what is interesting, or what interests me in particular here as a medical doctor by training, is that there's also changes. Now if you induce those illusions, this comes with consequences for how your brain represents your body. If you apply a touch cue, and people are supposed to respond very fast by a foot pedal response, whether they have been touched or not, they get much slower. They respond less well to stimuli applied to this body because we think the brain puts their self-foot into that avatar's body. More interestingly, for medical applications, you support more pain. So if you apply pain stimuli during the illusion, you wait a little bit longer until you say, hey, wait a minute, stop this now, this is getting too painful. We've also looked at the brain changes again that occur when this illusion occurred. Please play the next two videos, please. And we have seen one region, in particular in the right temporoparietal cortex, about 2 centimeters above and to the right above your ear. This is shown here in red. And this region basically monitors, under our experimental conditions that I've just presented to you, whether you feel self-foot, self-localized at the position of the avatar or at your body. So what we're basically controlling is inside or outside body experiences, if you want. So it's very easy to trick lifelong experience and to induce states and where actually you do errors. You do not know, as a subject of experience, where actually the subject is localized. And for me, this was very interesting to see, because if you apply an electrical stimulation to the brain of a person at the area that is indicated in blue, you have an out-of-body experiences. And this was mentioned in the title. Much of this research that I've talked to you about was actually started based on clinical observations where damage or interference to this blue region, which is very close to this avatar encoding region, has consequences. There, an out-of-body experience in this case, the subject feels, like is shown on the picture, to be under the ceiling, to be looking down, so the self is under the ceiling looking down, while actually the real physical body is still positioned below. So what are the conclusions of what I wanted to tell you here today? First of all, 2,000 years of philosophy it's great. It's a fantastic achievement, and this will inspire us for still a long time. But we have to stop saying that let's keep studying self-consciousness experimentally for another 2,000 years. I think we have to do it today, and some of these experiments I've shown you today says actually that we can change it. Spatial aspects of this, and we can change. And what I proposed is that this full body representation, the second part of my talk, where is your body in space, is actually the most simple and fundamental experience for feeling to be someone. The subject of experience is related to this full body representation and how the brain integrates visual, tactile, proprioceptive, and other stimuli. Now, cognitive neuroprosthetics aims at building models of these changes and then systematically use and employ them to animate, if you want to incarnate, brain-wise speaking, those artificial limbs I've told you, but also avatars, robots, and other forms of surrogate bodies that maybe we don't yet know how to think about it and how to conceive them. The first subjects, people, who will probably try these technologies, and we're actually having several ongoing studies in this field of cognitive neuroprosthetics, is tetraplegic patients or other patients suffering from spinal cord damage. There's a massive disconnection from the body depending on your level of brain damage. So you have a body, but you don't feel it. It's very similar to actually phantom limb sensations, functionally speaking. So what I would propose is to give these patients back a feeling of their body and to alleviate pain of this body, but because in some of these patients, actually, they not only not feel the body, but the body is perceived as painful. Actually, the technologies I've presented to you can change those two aspects. Entertainment may also profit from this. Video conferencing and video phoning has completely changed how we used to orally or verbally communicate. But it still, I think, has a long way to go. What I propose here is also that cognitive neuroprosthetics, projecting selfhood to a virtual world where you have an avatar and you meet your friend joining in as a virtual avatar from Australia, may change how we communicate and may facilitate communication even further, meeting, literally speaking. And I finish with this last video here that I also think for gaming, projecting yourself into the character, into the game, in something called first-person perspective games, if you can create games where actually your brain believes you're literally in the game, I think that will make for very interesting games at many levels of this field. For example, in the video that I show you here, the person or the self-representation is shown in this red avatar running in front of you. Now imagine that you can trick your brain to very strongly believing that that is really you. Literally, you will be in the movie, in this virtual reality scenario. Thank you. The final forgot to say the final conclusion, I will say thank you again after this, is that I believe in order to achieve this, and to achieve this fast, it needs a merging of several disciplines working on the same target problem. This is neuroscience, computer science, engineering, and last but not least, medicine. Thank you.